previous video, we have learned about the one-way analysis of variance. This lesson is on within group variation, between group variation, assumptions of one-way ANOVA. In this video, we are going to learn about how to visualize and quantify the within group and between group variations. What are the assumptions involved in one-way analysis of variance? How to validate the assumptions of one-way analysis of variance. To begin with, let us recollect the case scenario 1 we have introduced in the previous video. There, the researcher wanted to compare 3 independent groups, what is known as short-term psychodynamic psychotherapy, that is SPP, long-term psychodynamic psychotherapy LPP, and solution-focused therapy. So, these are the 3 groups the researcher wishes to compare, and he wanted to compare the mean of the working ability score of these 3 groups. So, basically these 3 groups I have focused. One group having certain observations that belongs to the SPP group, that is plus signs. So, those plus signs are representing the observations of working ability score of the subject belongs to this group SPP. And secondly, we have another group stars, those are the observations representing the working ability score of subject LPP. And we have a third group which is represented by triangles, those are the observations made from solution focused therapy. Now, to begin with, to explain the concept of within group and between group variances, we try to imagine what could be the central tendency measure of this group that I have represented in a bigger circle with a plus sign. So, this is representing the mean of the first group SPP, and moving to the second group, there is a bigger star, that means to say the mean of the second group LPP. The third one is a bigger triangle which is representing the mean of the SFT group. So, now with all this single means, we are trying to find out the overall mean, that is mean of the group means. So, mean of y1 bar, y2 bar and y3 bar, we call it as a overall mean or grand mean. So, with this understanding of the 3 groups with the 3 different group means, we try to find out what is the overall variation which is existing in the observations altogether irrespective of the group which it belongs. For example, you forget about the observation to which group it belongs. So, I have just reduced the points so that you will be able to better understand. So, here we have a set of observations, we do not have any group here. So, given this information or given this observation, how we can find out the overall variation? So, recall that variance is nothing but the sum of squares of deviation of observation from the means. Similarly, here I am going to try to find out what is the deviation of each of the observation from the overall mean. That is why it is called as overall variation. So, the overall mean is represented by y bar, and I am going to take the deviation of each of the observation from this mean. So, let me represent or let me assume in each there are 4 observations. So, there are totally 12 observations. So, I am representing those observation by y11 here in this, plus I am just representing y11, y12 and y13, y14. Similarly, the second I am going to represent the stars by y21, y22, y23 and y24. Similarly, then these observations of triangles by y31, y32 and y34. Now, what I am going to do is, I am going to find the deviation of all this observation from their overall mean, and I am going to take the squares of these deviations. So, I will start with first plus. So, y11 minus y bar the whole square plus y12 minus y bar the whole square up to y14 minus y bar the whole square. Then those sums, the sum of the 4 terms, I will introduce summation concepts which you know. Summation is for sum of the observation. So, here 1 is fixed. So, first 1 is fixed. So, we have an index term. So, we have an index term, 2 index. The first index is representing the position of group. The second index is representing the position of which observation, the number of observation. So, here the first 4 quantities are summed up like this. Summation j is ranging from 1 to n1. Here n1 is equal to 4. So, here all this plus we have 4. So, that is why I have written summation ranging from 1 to n1. Here in this particular example n1 is 4. So, for all these 4 quantities I have generalized it as y1j minus y bar the whole square. So, similarly when I move to the next set of observation, y21 minus y bar the whole square, y22 minus y bar the whole square, so on up to y24 minus y bar the whole square. So, again the stars have 4 observation. So, I have taken all the deviations of observation and I have squared it and I have taken the sum. So, similarly it moves to the next group. We are taking the deviations of all the observations which is represented in stars from the mean and we are taking the square and we are taking the sum. So, the 4 quantities, so the 4 set of quantities is represented by 3 different quantities, that is summation ranging from 1 to n1, summation ranging from 1 to n2, summation ranging from 1 to n3. So, here it need not necessary that the groups must have equal number of observation. You can have unequal number of observation, but in our case we have equal number of observation, that is 4. So, in the first group we have 4, second group we have 4 and in third group we have 4. So, this is a way you have to find out the overall variation. Now, we will try to understand what is within group variation. So, let us go to the first group, that is SPP. For this group we try to understand what is within group variation. So, now consider in this group there are 4 observations represented with plus sign and we have a group mean called y1 bar. So, now we try to find the difference between each of this observation from this group mean, that is y1 bar. Say y11 minus y1 bar, take the square of the deviation, again move to the second observation, y1 minus y1 bar the whole square. Like that you go on up to the final observation y14 minus y1 bar the whole square. Now, if you take the sum of all these squares of deviations, you will get one quantity what is known as within group variation. So, before you would have seen it was very general yij, but now we have specified it to y1j. It means it is the within group variation of the first group, that is why it is represented as 1j. Similarly, we can see this is called as the sum of squares of deviations of observations from the mean of the SPP group. So, in a similar manner we will try to see what is the within group variation for the second group LPP. So, again we have 5 observations. So, we try to take the squares of deviations of all the 5 observations such as y21 minus y2 bar the whole square, so on up to y24 minus y2 bar the whole square. When you sum all these squares of deviations, we will end up with a quantity what is called as within group variation for the second group. So, this is again called as the sum of squares of deviation of observation from the mean of LPP group. Similarly, for the third group, we try to accumulate the sum of squares of deviations of all the 5 observations from its mean, that is y3 bar. So, here you are getting the subscript as Y31 because the first index is for the group, the second index for the observation. So, third group, first observation. So, this particular observation is coming from first person, third group. Similarly, this observation is coming from second person from the third group. So, likewise, we have the 4 squares of deviation and we have summed it up. Finally, it has given a within group variation of this particular group SFT. This is called the sum of squares of deviation of observation from mean of the SFT group. So, we have learned about what is overall variation and what is within group variation. Now, with the understanding of that, we will try to understand what is between group variation. So, as I said, we have an overall variation y bar and we have an individual means of all the 3 groups y1 bar, y2 bar, y3 bar. Suppose if we have a 4 group, we have an extension up to y4 bar. So, previously we have taken the deviations from observation to its mean, but now we are going to find out the deviation of group means to its overall mean. That is why we are calling it as between group. So, we are going to find out the deviation of means from its overall mean rather than the deviation of observation from the overall mean. So, here consider we are having 4 groups. So, the first deviation is y1 bar minus y bar the whole square, y2 bar minus y bar the whole square, up to the last group is y4 bar minus y bar the whole square. So, one of the logic here is, if the between group variance is greater than the within group variance, more of the total variation is likely to be attributed to groups. If that is the case, it is more likely that the groups differ from each other. So, now we will try to understand what are the assumptions behind one-way ANOVA. So, the first assumption is the outcome or the response variable is continuous in nature. So, that is our working ability score is a continuous variable which has continuous measurements, and the population are normally distributed. So, whatever population we are dealing with, they must be normally distributed within their groups. All the populations have equal variance. This assumption we call it as homogeneity of variance assumption. And the fourth assumption is the measurements what we are making are independently assessed in each of the group. There are no outliers in the data. Outliers are nothing but the extreme observation which are far away from the rest of the observation. So, there are techniques are available to ensure whether a particular observation is outlier. Now, before choosing to apply one-way analysis of variance, we should validate whether our data suits to the assumptions or not. So, for that we need validation of all these assumptions. So, the first thing is, the first important assumption is the data should follow normality within each group. So, this normality test can be tested in 2 ways. One way is a graphical way, that is by making a quantile plot abbreviated as QQ plot. Next is, the next graphic is histogram. Through histogram, we will be able to understand approximately whether the data is normally distributed. And the third way is by doing a proper hypothesis testing. The test name is Kolmogorov-Smirnov test. So, by applying a Kolmogorov-Smirnov test, one can able to tell whether the data is normally distributed or not. As I said, outliers is one of the assumptions which need to be verified before we apply one-way analysis of variance. So, outliers can be identified by plotting a box plot for each group separately. Often this box plot we can use for comparing the between group means. You can look at this graph. This graph is giving you a visual comparison of 2 things. One is you are having some boxes, and along with that boxes we have two upper and lower lines that we call it as a whisker. So when you see this entire box is for one particular group, say A, and this second is belongs to the particular group B. Similarly, this is the box plot for the third group. Now if you see, there is a line plotted horizontally at the center. This line is nothing but the mean. Okay, so this is the mean of group A, this is mean of the second group, and this is the mean of the third group. So by looking at this plot, we will come to an idea approximately whether these three groups can be compared or not, and whether the means are equal or different. So secondly, this plot is also used for identifying the outliers, which is one of the important assumption behind one-way ANOVA. So that is here the outliers are represented by dots. So above this whisker, upper whisker, or below this lower whisker, if you find any point which is plotted, then that is called an outlier. So here in this we have 5 outliers, means 5 extremely lying away points, that is here. So here 2 observations are together, so it is seems like 8. So similarly here lower whisker, at the lower part we have 3 different outliers. So this is a one plot which can make you to understand approximately whether the 3 groups are different. Also it is able to identify is there any outlier information which is lying in your data. In this video, we have learned about within group variation and between group variations, what are the assumptions behind one-way analysis of variance, and we have also understood what are the ways of validating those assumptions so that we can apply one-way analysis of variance for our research data. We will continue in the next video, that is about assignable and chance causes and some variations of ANOVA. Thank you.